हमारे पिछले वीडियो में हमने कंप्यूटर प्रोग्रामिंग में डेटा स्ट्रक्चर्स एंड एल्गोरिदम्स के इंपॉर्टेंस के बारे में बात की थी. Today we'll be focusing on the different types of data structures that developers use to organize and manipulate data efficiently. So let's get started. The most common types of data structures are arrays, linked lists, stacks, queues, trees, and graphs. Let's take a closer look at each of these data structures. Arrays are a simple and popular data structure that stores a fixed-size sequential collection of elements of the same type. Arrays are easy to manipulate, and they are used in a wide range of programming tasks. Linked lists are another famous data structure that consists of a sequence of nodes, each containing a reference to the next node in the list. Linked lists are useful when you frequently add or remove items from a list. Stacks are a last-in first-out data structure that stores a collection of elements. Stacks are commonly used in algorithms such as depth-first search and backtracking. Queues are a first-in first-out data structure that stores a collection of elements. Queues are commonly used in algorithms such as breadth-first search and job scheduling. Trees are a hierarchical data structure that consists of nodes connected by edges. Trees are commonly used in algorithms such as binary search and decision trees. Heap is a specialized tree-based data structure that is essentially an almost complete tree. Generally heaps दो types के होते हैं, max heap और min heap. Max heap में value of the root node must be the greatest among all its child nodes, and the same thing must be done for its left and right subtree. Also, और min heap में value of the root node must be the smallest among all its child nodes, and the same thing must be done for its left and right subtree. Finally, graphs are versatile data structures consisting of nodes connected by edges. Graphs are commonly used in algorithms such as shortest path and network flow. In conclusion, the choice of data structure depends on the specific task at hand. By understanding the strengths and weaknesses of each data structure, developers can choose the right one for the job and create efficient and scalable software applications.